Hi, everybody. We are going to speak about implementing max. I'm not the first one talking about this subject. I heard a talk by Walter Brown on the subject, and there are many talks if you look for that, because it seems as a simple function, and yet we can learn, I think, a lot from that. And what I want to learn with you is mainly how to avoid dangling references, how to think about the contract of our function. For those who are watching the recording, we are just after lunch break, so the only way to keep you vivid is for you to write the code. So at a certain point, I would open a compiler and you would tell me what we want to achieve. But let's start with a short introduction of myself. My name is Amir Kirsh. I'm a teacher at the Academic College of Tel Aviv-Yafo, also a dev advocate at Incredibuild, a member of the Israeli ISO C++ national body, and a co-organizer of the core CPP meetup and conference. I would have a slide at the end about the conference. 2 slides of a very fast marketing plug. If you suffer from slow builds, come to Incredibuild. We sit over there, talk with us. We also accelerate Yocto. If you are from the automotive, for example, industry, or just using Yocto for other reasons, come talk to us. Implementing max. Is it that difficult? Well, I guess not, but otherwise we would not be here. So we want to seek for some of the difficulties. And the things that we want to consider in this talk are efficiency. We want to avoid redundant copies and allow move, if possible. We want to avoid dangling references, which is also something important, and to support different types. By the way, does the standard library studmax supports different types? I mean, I want to find the max of an integer and a double. What do you say? No, it doesn't. So you have to do the casting. You cannot send to it 2 different types. And we do want to support that in a way, okay? Optional, if time permits, most probably it would not, support returning reference for different lvalue ref types if one inherits from the other. So you can return a lvalue reference even if the types are not the same if one inherits from the other. By the way, it is quite difficult, maybe even impossible, to return lvalue reference if both inherit from some unknown other class. Because it's, I think, impossible without reflection to check if 2 classes share a base class. Anyhow, we would not have time, most probably, for that. Variadic PEX is just an extension. Once we have the thing working, if we have time, we would extend it to Variadic PEX, and not in the scope, not because it's not important, it's, you know, we can discuss that, but we would not allow changing the return value. We would stick with const return value. So this is the initial challenge. We have 2 strings. We call max. This is my version of max. I call it my max. And we send S1 and S2. And we want to get back a reference. So the first call seems okay, and the problem is that the second call, is it okay or not? Can it be okay? What is the problem that we might have with the second call? Yeah, I mean, we might have dangling reference. So the question is, okay, we can change on the second call max2 to be a value type, not a reference. Okay, but then the caller needs to understand when he can use reference and when she cannot. I mean, if I change it, why shouldn't I change it also on the first call? I mean, are you going with references or are you going with value? Can we make it work for both calls? Can we implement a max that would support both without dangling references? What do you say? Let's try. I guess this is the challenge that we want to take. And the idea is that if the second call, in a way, would return by value, then we would have lifetime extension. Suppose that the second call returns by value, then we are in the land of lifetime extension, which is okay. There is no lifetime extension for the temporaries that are sent as parameters. So the lifetime extension would be only if you return by value. But then if you return by value, then the first one is also fine. But what is the problem then? Efficiency. We wanted efficiency. If you can return the actual reference, we prefer to. Otherwise, why should you get it by reference if you know that it would be always by value? So let's try to have something that would be by value if there is no other choice, by reference if you can. This is the challenge, okay? And we would see that it is doable, but there are some obstacles at the way. So we're going to do some live coding, as said. This is max in the language, by the way. It changed over time, but mostly for adding const expression and other versions. But it gets 2 const references and returns a const reference. And if I implement the same, this is my max, which starts as the max that we have in the language. I mean, it looks similar. And I return a const ref. In all examples, I would use my string in order to trace whether the types that were being sent went through move or copy. So I have a my string, which I don't want to implement, so I inherit from string. And I had only 2 constructors, the copy constructor and the move constructor. I'm not going to use the assignment, so I don't care that the assignment is implicitly deleted. That's fine. The only thing that I want is to follow whether my string that is going to be sent to my max would go through move or copy. So this is the my max that we have in the language. If we call it with 2 lvalue references, we're fine. So here, we actually get the true value, no copy. And yeah, I think it works fine. I mean, you get the actual reference without copying. That's good. But what if I get these 2 lines of code out of comment? Let's uncomment these 2, maybe with the line comment as well. So I have here now the 2 temporary objects. And I'm running with address sanitizer. That's good because address sanitizer says, oh, you have here a problem with the dangling reference. If I would remove address sanitizer, then I think I can be happy. I think, yeah, it all works. I mean, we can ship, right? So there was a very important talk right before about contractual disappointment. Run with address sanitizer. Yeah, sure, I want to bring it back. So this is bad. I don't want that. But in a way, I do want. So one thing that you can do is to remove the ref. Okay, if I remove the ref, then you're fine. But there is a problem here. And the problem here is not only that, the contract is not clear. What is a contract? What do you expect? To get a reference, to get a value? Well, you get a reference, but you should not use a reference if you send a temporary, okay? It's a complicated contract. We can fall there. And the second issue is that we copy. We could have moved, I guess. There are temporaries. But yeah, they went as a const ref, then they were lvalue. So the question is, suppose that for some reason we say, maybe let's start with returning by value. Okay, let's return it by value. Okay, and you would see that we get a copy for both, which is not so good, but we have a decent contract. I mean, yeah, you know that. And if I want to get this one as a reference, I mean, can I extend the lifetime? Yes, you can. In both. Why? Because we return by value. But I would not say that this is the best approach. I mean, this is a start, but not the best start, right? So let's try together. I need your advice here to improve the copy here. Let's start with improving the copy on the two temporaries so we would get a move. What can you suggest that would achieve that? So there is a suggestion here to change the argument types to maybe to forwarding reference. So let's have two forwarding references. So let's see what happens here. Oh, we are in move. We're in move because we are in C++20. I would check what happens if we are in 17. I think that we would be in copy, but let's see what happens here. The forwarding reference is good both for lvalue and both for rvalue, but I even do not use any stood forward or stood move. So there is an implicit move on return, which was changed over the years. So if I go back to 17, let's take a look. 17, there is a copy. That's nice. Did you know that in 20, they added the rule that if you get an R value, you would, as a parameter, it would also would have implicit move on return, which was not in 17. In 17, it was only on a local variable, which includes also something that you got by value. So that's good. Let's keep it without the stood forward. I can add a stood forward here, but I think that there is no reason because I can change back to 17. Let's just take a look that if there is a stood forward here with a T, then, and I have to probably do that for both, so I guess that we go back to move. Yeah, sure, right? But you are in 20, you don't need that. By the way, you are in 20, right? Let's go back to 20. Okay, you are in 20. So there is no need for the forward there because there is an implicit move on return without the stood forward. Let's remove the stood forward, no need for that. And we are back to move. And just a short deviation, suppose that we return A is lesser than B, then return B, otherwise return A, and this is our function. So move or copy, what do you say? Copy. But we are in 20. Well, the rules advanced, but not so much. I mean, this is still an expression. So if you want to move, you need again to forward. So here, I think that you can forward the entire expression as, not here. So if I forward the entire expression stood forward, I know that they are both T, then I think that I would go back to the right thing, which is moving. Okay, nice. But no need for that. Let's go back for the return with a regular if. Okay, so we have our first move, which is we support returning by reference, we support moving, but let's go back to what we did here. We return by value. So the reason that we didn't get here any copy is optimization, right? It might be that we would have get a copy. We do want to return a reference. The problem is that, suppose that we say, you know what? Let's return this reference. What do you say? Well, there is a problem. We cannot return lvalue as an rvalue, right? Or this one is, it cannot bind rvalue. Yeah, I think that the problem is when it goes as an lvalue. I have to recall again what's the problem here, but no, we do not want that one. Another problem that we have is that, suppose that we want to call this function now with two variables. One is S2. Let's remove the constness from S2. Can we? No, we cannot. But B is not const. Oh, that's nice. B is not const. S2 is const. So let's go for this one. Okay. We want to call our max now. Okay, with two two arguments, S2 and B, both are strings, both are my string, but we cannot do that. And the reason is they do not share the same type. So the compiler deduces two different types which cannot go, and we do want to support, this was one of the requirements. By the way, we do not support int and double as well. And we would like to support that. So what should be the next step if we want to support? Yeah, you should be able to support two types. Yeah, we can do some auto here. Yeah, that's a good idea. But I don't know why. I prefer maybe because I would like to do some forward later. So let's have T1 and T2, and then we say, okay, T1 and T2, but then the return would be auto, right? And we do hope that it would work. Yeah, okay. We now support two different types. Okay, that's nice. The auto would do the common type. The auto would do the common type. I can say it verbosely, but there is no need. There was a suggestion here to use stud common type, but here I think that I don't need that. Can we add other things? Like suppose that we have a char star, okay? And we want to send char star and my string. Now, both char star and my string should have a common type because char star can create a my string. I think it can. Maybe it's two. Do I have? No, I inherited the constructor. So yeah, through this constructor, it should be able to create my string. So I do have a common type, and there is comparison between the two. So let's try these two. Inconsistent deduction for auto. So yeah, we have an issue here because, well, we would like to solve that maybe with common type or something. Let's put that back in a comment. So I would go back to the fact that we return by value. And I want, in a way, to say, okay, we want to differentiate between the two cases where you got two lvalue references, in which case you can return by ref, or you got something which either of the two is not lvalue ref, or maybe they are both lvalue ref, and you still want to return by value, in which case I got two lvalue refs, and I still want to return by value. And the reason is they do not share the same type. Once they do not share the same type, then the compiler needs, in a way, to create a temporary. Or it might create a temporary, in which case I do not want to return it by ref. And again, I can return it by ref as long as you are using it or not using it. As long as you do something with it in the immediate statement on the return itself. But you cannot take it by reference, and this is a bad contract, which we try to avoid, right? This was the idea. So in a way, what we would like to do is to have two my max, like this is one, and maybe another one that would say, you know what? There is a case where if you know that you got this and this, then maybe I can go for the ref. Okay, I have two, right? Maybe I have to add a printout so we would know which one we reached, right? This would be one. Oh, I can just add. This would be one, and the other would be two. Okay, so the first case is two references, and it's good. It got to one, right? The second case also got to one, right? It seems so. Which, this is the second case, like 46. We have two temporaries, right? Something is not so, oh. Yeah, I think that I printed. So the problem is the second one goes to one, which is okay, right? I return by value. The problem is with the first one. The first one goes to 1. So it seems that the first one that gets 2 lvalue references gets to the first implementation, which is a bit too greedy, right? The first one says, I'm getting rvalue. What is the reason that we didn't go to the second one? Yeah, they are not const. Maybe we can add const for both. Okay. And then we would go to the second one. Oh. So what we need to ask our users is, when you send a string by ref and you want to get a max, please do const cast, right? This is the way to do that. Or maybe we can do better by allowing you to send something which is not const and still create or return by reference. So if we want to be less greedy, or at least, say, yeah, we do support non-const, or maybe we even do support, the variations, the mix of one is a const and the other is not, then we would try, we would go for, at least for the first step, with saying, you know what, let's call this 2a, and then let's use the 2 keys that most programmers love the most. Let's copy that and say, oh, I have another one. The other one is 2b. And what would be the difference? It would accommodate, let's say, 2 non-const. Well, that's not enough. We need also 2c and 2d. And luckily for us, we deal only with 2 arguments. Suppose that there were more. Okay, so some more combinations. It's not so bad. Anyhow, this would be 2c, this would be 2d, but we need also to change the signature. So eventually, I think that we would support, I guess, I hope, all variations, and it did get to the last one. Good for us. We can go to the reference one if we have 2 references. We can go to the return by value, which is the one listed as 1, and then we move, okay? Which is good, which is nice. The problem is that I don't really like the copy-paste here. So what should be our next step? What do you suggest? I can remove the constness in the declaration. In which of the functions? So I did that. This is the function that you talk about. Oh. Okay, so there is some idea of template metaprogramming, like, I don't know, requiring something maybe, or sphinxing something. At the end, what I want is, in a way, to merge all these 4 and say, well, all the 4 here are the same. But I just want to say something about all these, right? So in a way, to merge all 4, what can merge all 4 to something that says, well, I'm representing all 4? We have the answer. And the answer is forwarding reference. So we are back to square one. We already had it. Okay, let's do that. The one that can accommodate all 4 is a forwarding reference, but it is being used now for the rvalue case. Okay, so I'm deleting all these and coming back to, okay, I'm with this one. So we need 2. We need 1, and then we need another one. Okay, that's cool. We're done. Oh, the problem is that we need, in a way, to say that we reached one of them. No, that's not the problem. The problem is that we need to differentiate between the 2, right? So we need to require something. And the question is, should we require one of them to get rvalue references, or should we require one of them to get lvalue references? What should be the approach? Or it's just, the same. I mean, I'm going to use C++ requires, C++20 requires, in order to require one of the functions to have T1 and T2 be lvalue, or to have one of them be rvalue. Should I go with the rvalue approach? Suppose that I ask whether T1 and T2 in the first function, one of them is an rvalue, if one, I wanted one of them to return const ref, right? This is, but of course, the difference in the return type is not enough. I want the first one to accommodate for, one of us is a real rvalue. So suppose that I add requires, if one of them is an rvalue, I want to be here to return by value, because I don't know which of the two is going to be returned. So if one of them is an rvalue, okay, I must return by value. So the question is, if I add here a requires clause that says something like, you should help me here with some type trait, right? Should we need also concepts? Maybe. So stood, I think something like, it is not going to work, and we will discuss why. Is rvalue ref, don't forget the V, I think, about T1, right? Or if the other one is rvalue, if one of them is rvalue, then you should go here. No, something is not good with is rvalue ref. Reference, yeah, I am too short of characters there. Reference, thank you. Okay, and let's put it here as well. So I'm requiring, we can do it a bit more organized. I'm requiring both to be rvalue, something like, no need twice requires. I'm requiring them to, and I get a, it compiles. What's the problem? So if there is a suggestion here but I ask whether one of them is an rvalue. So I will tell you that I never go here. I mean, this one is never selected. I crash here. Why? Because you select in line 48. I think that the problem is, usually people say, don't use to the end line, use \n. And I say, no, I do want, because I want to get the printout before the crashing. Not, there was a printout, but we didn't see it because we crashed. No, I want to see it. Okay, I think that now we would have more information. Okay, we went to the second one, even in the case that we are rvalue. And the reason is quite simple, and it is reference collapsing rules. Reference collapsing rules say that if you got rvalue reference, by reference, it means that the reference binds to the double ampersand. And your type of T is the value type. So it's not an rvalue reference, the T1 and T2. They are not references at all. So no, you cannot do that. It would not work. You can do something else. You can ask if they are, but then you need, I think, parens. If they are not reference, is reference, it should not be a reference, or the other one is not, which means exactly what we wanted to ask, but it is not so expressful. I mean, well, I ask, and it goes to the right one. Because, it was not a reference. Yeah, it was a reference, but the reference was cached by the double ampersand, and then the T was the actual type. I don't like that. I mean, it would be better to put the requires where? On the other one. So let's go to the other one and say, no, I want you to be is lvalue reference, and of course, change this to end. And the other one, your friend, should also be lvalue reference, right? Lvalue reference. And here we go. But we're not done yet. So let's see what we have. We have two functions. We distinguish between the two using C++20 requires. Oh, you do not use C++20 requires? You are with C++17? Don't worry. You can always use enable if with fancy Sphina, right? This is what we love. Move to C++20 requires is much nicer. Anyhow, we can do that. We can differentiate between the two. That's good. Are we done? Not. No, we are not done yet because this one bothers me. I think it should compile. I think that let's try. At a certain point, I think that we can compile it. Here, inconsistent deduction. Okay. Well, we do have here two types, right? T1 and T2. So in a way, it should go to one of the functions. I mean, I have here a string, my string, and a child star. And I do want to support two types. I mean, let's try it with something a bit simpler. Let's try to call my max with double and int, like 5 and 5.5. Should it work or not? No, inconsistent type. So in a way, I want to support both types. Let's see the problem. The problem is that it goes to the by value, right, with two types, int and double. And the deduction for auto return type is not good. So, okay, we can fix that. Maybe with a suggestion that we had before, maybe auto is not good for us here, and we have to use, we can replace it with common type. So let's do a stud common type. I think it should be common type T, right? Otherwise, we just return the common type, not the common type type. We need the type of the common type. And the type of the common type is the type of the common type of T1 and T2. So this would be for the first one. And for the second one, I don't know, let's leave it as is. So let's try now. Let's try, what did I do with the doubles? I was so mad at them that I deleted them. Okay, so let's try this one. Okay, and we are still inconsistent. Something bad here. What's the problem? 35, line 35, we would go there, record from 35, inconsistent direction 4. I think that the problem is that they are both, there is an issue, I think that there are references. I need maybe, yeah, it's before that, even. No, it's a return, So it's required from 63, and 63 is, let me just, it doesn't work, anyhow, 63 is this one, right? Okay, so I think that the problem is that a common type, there is also a common reference, right? Or common type of remove, it should be stud, remove CVRef of T1 and T2, something like that, right? We need to remove the CVRef of both. And again, don't forget the T. Otherwise, we are returning the common type of the remove ref. Okay, maybe now, let's see. Remove CVRef is not a member of stud. Maybe it goes like that. You should help me here. You can open CPP reference. Okay, back to not working. Any suggestion? It's complaining about? Oh, the second function. Yeah, thank you. Okay. But I think that the remove ref was required anyhow, I think. We can check that. Okay, so thank you. Oh, and you were saying that all the time and I didn't listen to you, sorry. It's because you are front row and I see to the back. Okay, we just get a warning now, but it works. Okay, that's good. The warning is something that would, I think, would eventually crash. So do read warnings or run with the sanitizer, or do both. We have an issue. We want to check that, we want to fix that. I want just to make sure that we actually needed the stud remove CVRef. I think that we did have the need for that, yes. Because otherwise we try to find the common type between two references, right? And we want the common type between two value types. So we say, and maybe one of them is const. So eventually we say, just remove the CVRef of both sides, and then we're I mean, we're almost fine, because we still have a problem here. Can you tell me what is the problem? What is the problem? Yeah, so there is an answer here that we are reaching the first or the second. The one that crashes us, the second, and the second tries to return the second here. And again, it's good that we use n-line instead of \n, because we see the printout. I was debugging things with, oh, you need to prefer \n. You do not see the printout. You think that you crashed before. No, you crashed after. It is waiting in the buffer. So student line, we see that we went to number 2, which should not be the one that we should go to, right? Why? Because one of them is going to be a temporary at the end. I mean, we're going to return a my string. In this case, we're going to take str, which holds str, which is bigger than, is it bigger than s2? Might be, yeah, it's s, the other one are h. So we're trying to return a my string from 2 L values, but they are not the same. So there would be there a temporary object. We're in trouble again. No, I want to stick with 2. I want to stick with 2. I just have to add another requirement to my requires clause, right? I just need to say, oh, you did require them to be L values. There is one more thing that you need to require them. And this is to be of the same type. So I say, okay, and just bear with me, if you may. It's not enough that they would be both L values. I want you also to check that they are std same as, I think this is a concept, which means that it doesn't need the v. It's a Boolean expression at the end. And the 2 that we send are, I think it should be either T1 and T2, or again there. Oh, not this one, right? What you are saying is that we are, no, this is the second one, yeah. I'm on the second one. I can use the is same, but I think the same as would work here, and it would take 2. I mean, a concept can take 2 if it is not being used on template parameter. So here, I should send both T1 and T2. I just think maybe, is there a need to send the CVRF? I see that some of them are going to 2, this one. But the first one, line 41, is now going to the first, which bothers me a bit. And I think that the reason is that one of them is const and the other is not. So again, same as, bear with me, sorry, stud, right? Remove CV ref, right? T. Don't forget the T. I mean, we do forget the T if you are doing things like that, and then we sit on that sometime. And, right, I think that now I forgot some underscore between, oh, without the underscore, yeah, thanks. So, it's good that you came, thank you. Okay, and now I think that the first one goes to the second, which is good. The second goes to the first, right? This is what we wanted. And the last one works, which is nice. I mean, we could have ended here, but I'm a bit more ambitious. I want, if you may, to group the 2 functions to a single one. I want to make it a 1 function. I want at the end to have a 1 single max function that would accommodate both the we need to return by value case and the second case that we can return const ref. How can we do that? We should, inside the function, on the return type. Yes, we can do that with a conditional if const expression or something like that inside the function. Yes, we can do that. That's possible. Another approach that I would take with your permission and help, I hope, is to create some kind of a type trait that would look at two types and decide on the proper return type given two types. I mean, okay, I got these two types. Oh, you need to return by value. Or I got these two types. Oh, you can return them by ref. So I'm trying to, I would like to create a new type trait that can look at two types and create the proper return type for these two, okay? So it would look like something like struct, how should we call it? Let's call it return type, okay? Return type, and it is templated over. Yeah, I think that we need here a template over some class T1 and class T2, okay? And what I want inside is something like using type equals, let's start with equals T1. No, but we want something a bit more sophisticated than that. So what should be the type? Well, we wrote it something like that, okay? This is one case. Okay, this is one case. Let's take a look. So the first case, or the primary template, would be, you are the common type of the two, but maybe, yeah, by value, as is. Okay, now let's add the specialized version, right? Okay, so for the specialized version, we would have one that says, if you got T1 and T2, that it doesn't like me now, because the specialized version is the same as, I need to require something. I mean, I wrote this one, I can just take it from there. If the two are complying with this, right? Then I can say, you know what? I want something very similar, but not exactly the same, something like that, right? Any suggestion or question? Oh, you say that they are the same, so instead of saying T1 and T2, I can say here only T, and then inside, I just have to ask, but I think that then if one of them is const and the other is not, I'm in trouble. No, we do support one const, the other not, if they are the same type. So if I join them both to be T, then I lose this case, and I do want to support one const, the other not, both are L values, go here. So if I have two T's, maybe they're the same, maybe one of them is const, the other is not, but they are both L value references, and if you remove the CV ref, they are both the same, then this is my return value. Yeah, sounds good. So I think that we are ready, I think. Oh, I put it just above the my string. It bothers me a bit, because my string is, is just for the, okay, now we have the two return types, one and the two, the second. And now I believe that we can just remove one of the functions, okay? We would get here again, I guess. Oh, now we are back to, we always return by value. No, we do not want always to return by value. So instead, what I want to say here, it would be even shorter. It would be nice. What is the return type? Yeah, the return type, let's call it, we called it already, return type. That's a nice name. T1 and T2. Okay. Type. I don't like this type. I prefer this one, right? But for this, I need, some work to do. Okay, so let's do some work. Using what? Return type t equals to return type of t1, t2, colon type. Okay. And now I think that we are fine, and oh, something is not good here. What's bad? What's not working? You should help me here. I always go to the first one. Can you assist me? Oh, I know why. There is a good reason. There is only one. Okay, so maybe we need to just remove this printout, but we can see that you do move. The fact that you move says that, well, you move. It means that you returned. So we can check inside, but eventually you do not copy, you move. So I think we did what we wanted in a way, and we have the return type and a single max function that returns by value when you need, but by reference or const reference in this case when you can, which is nice. We do not have something like that in the language. Maybe we should not. Maybe it's all just a play. But I say that we have now a better contract. The contract here says, let's take a look back in the main. The contract here says, you can take me by reference. You can take me by reference even if one of the two is an rvalue. Don't worry. Why? Because I would return by value in this case, and you would get lifetime extension. I don't want to use lifetime extension usually, but since I prefer to know that I can take by reference, I mean, otherwise I'm a bit, confused. Should I take by reference or maybe not? Take by reference. You would get either a real reference or lifetime extension. That's good. Okay, so we have a better contract, I would say, and we do accommodate all cases include. Let's do now by the way, okay, we would leave the last one for the end, but let's add here the stud max, my max, sorry, no stud max, my max for what we wanted is 5.5 and 6, let's say, right? And we want to print it, I think. Let's print it. So, who's bigger? I hope that it would work. So, we want the maximum of, what happens here? C out. Here it goes. Okay, and did I forget some semicolon somewhere? 69. C out, my max. What's the problem here? Oh, it gets compiled. Okay. Okay, yeah. And the maximum is 6. Hooray. And if I put here, yeah, I think we can play with that, but it works. And if I would go to studmax, what about studmax? Can you do that? No. Int and double. No. Give me 2 ints. Or 2 doubles. Yeah, I can do that. I can say static cast to double. It might be a variable, I mean, so yeah, I can do that eventually. But I think it's nicer to be able to do that, to send 2 different types that you can find the max out of the 2. I think that we almost done it all. This is the thank you at the end, but we are not yet done. It says in Hebrew, toda. Anyhow, I want to get back to the slides. We would not do the Variadic template case, but I would tell you that the Variadic template is not so complicated because you take the same idea and then use fold expressions, etc. Okay, it's doable. So let's see if I have some more slides. Yeah, I do have. So we did some live coding. We eventually add one my max that behaves differently for 2 types, and a few references. So the main resource for this talk is a question in Stack Overflow. And I shamelessly stole the answer from there. it's okay because I wrote the answer. So this was the question there. And it started with something very similar. What should I use? Would they work together? And the answer, not so. And then I started with, well, you can do that, or you can do that, or maybe you can better do that, or if you may, you can do that. And this is what I was discussing here. There's also a link over there to a Variadic template version somewhere else in Stack Overflow. I would tell you that answering questions in Stack Overflow is something very educational, because you start with something, and then you feel that you learn while answering the question, right? So it's quite nice. I do recommend doing that occasionally. And there are additional resources on that, including one by someone, Andrei Alexandrescu, in 2001. And he's discussing the rvalue references before they were there, because temporary objects were there already. It's a very good read, even though it is, I think, it is archived somewhere. It's from Dr. Dobbs. Three final things before we depart, which are not related to the talk.